At dawn, the desert turns white in minutes. Then the streets become glass, not roads. Why does one tiny city freeze so strangely? The answer starts with a mineral, not weather. Some places are shaped by ice. This one is shaped by salt, dust, and altitude. And the strangest materials on Earth keep appearing. The city sits high in the Andes. Thin air changes everything up there. Dry air lets heat escape fast at night, so even desert towns can wake to frost. But that is only the beginning. The ground below matters even more. Rocks, salts, and old deposits trap water differently. That changes how cold air behaves, and it changes where snow lands. Look at the white crust on the ground. It is not always snow. Sometimes it is salt left behind. Water rises, evaporates, and leaves minerals. That process can build bright, fake snowfields. Salt can reflect sunlight better than darker soil. That makes the surface heat unevenly. Uneven heating shifts local wind patterns, so the city becomes a weather machine. Now the scene changes again. A street can look frozen, then suddenly sparkle. That happens because moisture sits on mineral crusts. A thin film can turn dangerous fast. The ground is not simply cold, it is chemically active. Now zoom into the minerals themselves. Some look ordinary. Some quietly control entire landscapes. One famous example is lithium brine. It sits underground in salty water. The water looks harmless from above, but it carries valuable dissolved minerals. When it evaporates, rare crystals remain. Evaporation can separate minerals like a giant natural filter. Sun, wind, and dry air do the work. Factories copy that process in pools. Nature did it first, and faster. That is why salt flats matter. They are not empty. They are mineral factories under the sky. And some of the brightest satellite images come from them. The next clue is even stranger. Black sand beaches can hide magnetite. That mineral is naturally magnetic. Walk across the shore and it looks normal. Bring a magnet close and the sand jumps. Tiny grains suddenly become a moving crowd. Magnetite is heavy compared with ordinary sand. That weight helps it collect in certain places. Rivers wash lighter grains away. The magnetic pieces stay behind. So the beach gets sorted grain by grain. This is why some desert edges shimmer. Different minerals separate by size and weight. Wind makes tiny dunes. Water makes mineral layers. Time makes both look simple. But mineral weirdness gets even wilder. Some crystals grow with perfect angles. Others crack in patterns called cleavage. That means they split along weak planes. One tap can reveal a mirror-like surface. Think of a rock that opens like a book. That is not a metaphor. Some minerals really do that. Gypsum can form huge transparent blades. Some are as clear as window glass. Others look like frozen swords. They appear in caves and dry basins. The chemistry is simple, but the result feels impossible. Gypsum contains water inside its crystal structure. That hidden water changes everything. It makes the mineral softer than many stones. It also helps create giant crystals in dry places. And those giant crystals need a very specific world. Warm water, slow evaporation, almost no disturbance. That is why some caves stay famous for centuries. The mineral can keep growing in silence. Now jump to a different kind of strange stone. Pumice can float on water. That sounds fake until you hold it. It is full of tiny trapped gas pockets. Those pockets make it light enough to float. Pumice is volcanic rock, not foam. It forms when lava cools fast. Gas escapes so quickly that bubbles freeze inside. The rock becomes a natural sponge. That is the same logic behind many useful materials. Air changes density. Density changes behavior. Behavior changes everything from building stones to shipping. One element at a time, the world gets weirder. Some minerals even change color in different light. Opal flashes when you tilt it. Its structure bends light instead of absorbing it. That makes the stone seem alive. It is really geometry, not magic. A gemstone can hold a rainbow inside. Yet the trick is only tiny layers. Microscopic spacing creates the fire. That same idea appears in snow. Snowflakes are crystals with repeating geometry. Temperature and humidity shape each one. No two are identical because the growth path keeps changing. The pattern is nature's signature. But in deserts, snow behaves differently. Dry air can sublimate it fast. That means ice skips the liquid stage. It turns straight into vapor. So the white street cover vanishes almost as quickly as it arrived. Sublimation is why desert snow can disappear so fast. Sunlight and low humidity pull water apart. That leaves roads slick and unpredictable. The danger is not depth, it is the sudden change. And here is the hidden trap. Dry sand under snow does not grip well. Vehicles lose traction. Footsteps slide. A town built for dust suddenly acts like a skating rink. Some minerals also store temperature itself. Rock salt can preserve cold in shaded pits. Clay holds moisture and slows heat flow. Dark basalt absorbs heat during the day. Light gypsum reflects it back. The ground is always arguing with the sky. Color matters more than people expect. Dark surfaces heat faster. Light surfaces stay cooler. That difference steers local air currents. Tiny differences become local weather. This is why map views matter. From above, you can spot mineral zones, white salt pans, red iron-rich slopes, black volcanic fields. Each one tells a different climate story. The city is only one small chapter. Some of the most useful minerals never look valuable. Bauxite begins as dull red earth. It hides aluminum compounds. Later, industry turns that into metal. Your drink can, your bike, and your airplane all depend on that chain. Aluminum is valuable because it is light. Nature locks it inside ore first. Energy unlocks it later. That is why old rocks can power modern life. The same idea reaches your phone. Lithium helps store energy in batteries. Cobalt and nickel often join the mix. These are not glamorous minerals. They are the invisible gears of modern machines. And they often come from landscapes most people overlook. A dry basin can help power a city. A salty pool can hold a battery. That is not science fiction. The weird part is how concentrated some deposits are. Water moves through rock. Heat changes what dissolves. Evaporation concentrates what remains. Over time, a landscape becomes a vault. Natural concentration can happen without digging deep. Rain, wind, and heat do the sorting. That saves energy for miners. It also creates fragile ecosystems. So the mineral story always has a second side. Now look at ice in the mountains. Glaciers grind rocks like sandpaper. They leave flour-fine sediment behind. That powder can color rivers milky blue. It can also feed new